So welcome everybody to this TWED Talk. It's a reminder that next week is RPI's spring break?
Spring break.
It is officially spring break.
Yes.
So since all of us are going to be in Bermuda, there won't be any TWED Talk. There won't be. Tim was going to give a part 2 of his DataFAQs talk next week, and I think you're still going to do that. But
I'll do that remotely.
You'll do that from Bermuda. All right. So, anyways, we're welcoming back to the podium Tim Lebo. This time he's going to be talking about his work and his collaborators' work on the DataFAQs service when 5 stars are not enough. Take it away, Tim.
Thanks, John. Yes, so I'd like to talk about introduce DataFAQs and the outline of that introduction. We'll basically start with, it'll be 2 parts, starting with motivation and contrasting linked data production with linked data monitoring, and pointing out some points that I think that we're still missing in the linked data monitoring side. And then I'll walk through just the 3 essential aspects of the DataFAQs framework, where you choose data sets that you're interested in evaluating, you choose the evaluation services that you provide a variety of measures that you're interested in, and then finally you can explore those evaluations. And then I'll talk about how DataFAQs is built on top of a linked data framework itself, so you have the nice advantage of being able to evaluate linked data and providing those evaluations through linked data itself.
So Tim, I'm sorry, before you dive in, could you just give a little bit of context for who's working with you on this, either directly or indirectly?
Yeah, so I mean, a lot of this has really spun out of the experiences from the Linking Open Government Data project, right? So the lessons learned of the last 3 years that we've had with that project. So everybody that's a member of that team really has a part of this. Jim McCusker, I'm using some of his SADI work. He actually introduced me to SADI, so that was a heavy design aspect. I'm using Alvaro Graves' loudspeaker to be able to present a lot of these evaluations on the website as well as linked data side. Yu Chen, who was here earlier, he was up in the library still. Yu Chen, who did an internship at Franz this past summer. We share some data quality interests, and we've been talking about that, and we're working to use DataFAQs to do his evaluations. And hopefully, I've been talking to Josh, and I'm really excited to have the opportunity to incorporate Ripple into DataFAQs as well when you implement an evaluation service, which is, I think, a really great complement to the Python-based evaluation services. So those are the folks that are helping out. I've been doing a lot of implementation and getting some design inspiration from them. So as most of you know, there's this tool that I really like, and it has a really long and hard to pronounce name. And it converts tabular data into well-structured, highly connected RDF data that's it can be then posted as linked data. Wow. So I guess the interesting the niche that this converter really handles is kind of the environment that the DataGov provides, right? So so in an effort to expose this data, they got it out quickly, but we have a DataGov guy in the crowd, so they got it out quickly.
Say whatever you want.
But it's relatively difficult to grapple with what is there, right? And so a lot of it is in tabular structure with no schemas, no data typing, and so it's very very ad hoc. And so this tool developed.
Did you tell our leaders that?
If you need me to, no problem. So really, this tool was developed out of an environment like that, where a third-party organization, namely RPI, is able to consume a variety of different data from different data sources, and then rehost that in a more integrated, more holistic, higher quality linked data. And so, really, it's meant to be an augmentation, an annotation to the existing data structures, to provide external representations for how to interpret that tabular data. So this is what we've been using for the Linking Open Government Data project. We've been working with data.gov. So just a quick story that kind of motivated kind of the outline for this talk. A couple of weeks ago, I got an email from the LATC project, which is the Linked Open Data Round the Clock project in Europe. And they emailed me and said, hey, we'd like to list your tool in our tool listing. Would you mind going and filling out the survey about your tool? I said, sure, no problem. So so there's this data set listing. And so I went to this Google survey, started filling out some of the questions that they were asking me, and what other tools are in the same market? And so I keep tabs of all the other tools that do my kind of stuff, and so I just pulled up my GitHub wiki page and kind of pulled out all the names and everything, and managed to quickly put together a list of 30 other tools that kind of fall under the category of tabular to RDF, right? And so I think the only appropriate response to this list is some combination of these punctuation marks of holy cow, why so many different tools to do these things? And so clearly there's some reasons that motivate these different tools, and some different characteristics among them. So I'm not sure most of you are familiar with the LAD2 project in Europe as well. And about a year ago, they provided this deliverable for their project that is a report of knowledge extraction from structured sources that analyzed about 25 different knowledge extraction tools. One of them was the CSV RDF for LOD. And I think it's very useful to take these surveys and to kind of look at the different characteristics that the tools have. And in the table that they provide, and the characteristics that you look at basically falls down into these 8 different characteristics that helps you categorize these different tools. Starting with the data source, as a CSV XML, data exposition, are you extract, transform, load, or are you sparkling back to an original source? Data synchronization, do you just kind of do it once versus being able to come back to the original source? What kind of mapping language do you use? Do you reuse existing semantic web vocabulary? What kind of automation is it? Is it manual? Is it GUI-based? Is it semi-automatic? Does it have heuristics within it? And does it require a domain ontology to promote the data that you have available into the end product? And finally, does it use a GUI? And I think my response to that is, I think we're looking at the wrong things in these kinds of surveys. How these tools work and how you accomplish these things, I don't think is the essential aspect. I think the more important aspect is how well are they doing it, or why are they extracting this knowledge for the particular data structures. And so it's not, the focus shouldn't be on the publisher of the data. The focus should be on the consumer of the data, so that we focus on why this data is actually being used. And so I'm going to give 3 examples of projects that are focusing on those kinds of aspects.
If you could go, so looking at your question, you can kind of see them through there. they don't actually, none of the questions have to do with how results are presented.
It's all focused on how the tool does its conversion.
Yeah.
Not what it produces or how well it produces it or why it produces it. So it's just focused on how do I convert data. But there are other groups, and Lab 2 is one of these groups that I'm going to talk about, that is actually looking beyond how to just do it and trying to understand basically the variety of aspects of the quality of their output. And so Mondeca has a Sparkle endpoint status that's actually derived directly from CCAN's the Data Hub listing, which is the listing that leads into the LED diagram. And these two columns have uptime in the last 24 hours and then uptime in the last 7 days. And I think that the color coding on the left is currently. Interestingly enough, the LATC folks who were doing the survey for my tool, 0%. So they need to pick up the pace. So the nice thing about this is that you can get a quick glance at the entire linked open data cloud, what's available within triple stores and how reliable they are. So this is focusing on accessibility of the data, which has some use because if you can't access it, then really wouldn't consider it linked open data. So another project, LodStats, has come out recently. I just went to the website this afternoon to create the slide, and I found, hey, they actually found one of the data sets that I created in the end of February, February 29th. And so this is just a data set that I created to hold an RDF representation of some vocabulary mappings for the provenance, a variety of provenance vocabularies. And so LodStats is kind of a triple streaming implemented Python process where, again, they're driven off of the CCAN listing for all the LED data sets or log file data sets. And you get some good statistics on when it was last modified. And interesting is being worked on false. Well, I just made it within a week ago, so I guess I'm not working on it anymore. But they give you the number of triples that are in there, the number of entities, number of literals. You can toggle open some classes. The defined classes are 0, which I'm surprised about because my converter provides vocabulary with converted data as well. So I'm surprised. I'm curious on seeing how they actually link to those, as well as properties and data types, and a variety of different statistics, which is useful. So in case anybody was ever wondering, the linked open data cloud is about 2¼ inches wide. So we can put that to bed. And finally, the linked open vocabularies, which Pierre was here presenting this past summer. So this is more focused on the vocabulary that's being used within linked open data, again driven off of the CCAN listing of all of the linked open data sets listed on the datahub.org. And this is focused on the vocabulary that are used, and I sorted this one by the linked open vocabulary distribution. So the most distributed predicate is DC terms title, and actually the top 4 are all DC terms. So this is focused on the quality aspects of the linked open data, focused on the vocabulary that's used across those different data sets. So where does that put us with the linked open data, the state of the linked open data? So really, with publishing, problem pretty much solved. Plethora of tools, we can get the data out there, but where are we with monitoring? And I give that a so-so. So we have these. We're starting to do these analyses, these meta-analyses across the different data sets. Are the endpoints up? How many triples do they have? The statistics are available, and we can look at the vocabularies. But my general concern with these kinds of systems is that they're too heavyweight and they're too centralized. right? So somebody sets up shop, somebody sets up an endpoint status. And they have their particular insights on their perspectives on what they want to see, and they create the system to do that. But where's the little guy? What about the linked data consumer or the smaller linked data publisher who's interested in a particular aspect of the linked data? How can they perform this monitoring or share their particular view on what the linked data, how they view the linked data to be either poor or high quality? So how do we give this little guy a chance when all they need to know is this X? When X isn't an endpoint status, it isn't a number of triples, and it isn't a vocabulary linking problem. And so really I see this problem as an area where you compare the technical and the social aspects of linked data to the consumer and the publisher aspects of linked data. And over the last, say, 5 years, we've really nailed this technical publisher problem, right? And a lot of those tools that I presented were created within those last 5 years. And as far as being able to consume at a technical level, then yeah, we dereference and things like that. And the social aspects of publishers is somewhat there when you looked at the linked data diagram where one data source refers to another, right? You could kind of view that as a social aspect where I'm linking my URIs to your URIs, and so you're getting that connectivity. But when you start to tip the balance towards the consumer or the social, I think really that's where the shortcoming is within data today. And so that's what trying to address with DataFAQs. And again, just bringing out this last point of these guys are systems, right? You set up shop, you do an analysis, you give some results. There's no way for the little guy to plug in and to give in their little voice about what they're interested in, both at an application level or a particular domain level. So we need a framework here. And so that's what the design of DataFAQs is trying to achieve. And DataFAQs is about linked data quality reports. And it revolves around these 3 dimensions where you have the data sets, which can be very broadly understood. You could look at a user's Flickr images as a data set. Right? The content need not be linked data. It just simply is represented or described in terms of linked data. And the new dimension is the evaluation services, where you have these focused, almost myopic perspectives on individual data sets. And when you provide the data set metadata to the individual evaluation services, it's going to do something. It's going to tell you what it thinks about it. And what comes back is actually an RDF description of that evaluation service's perspective. And so in that cell, in that matrix, is the evaluation. And so we can do this over time. So we can do this every day or every week or however often we want. And for any one of these time slices is what I call an epoch. So that whenever you kind of do that nested for loop of for all data sets and for all evaluation services, whatever you collect back, all of that data is within a single epoch. So all of DataFAQs is going to revolve around these 3 dimensions, with the evaluation being within the cell of each of these dimensions. Now, I brought up the point of the distinction between a system and a framework, and I'd like to emphasize that again here on this slide, where when you use DataFAQs, you create and maintain your own fact brick. So John's got his here, and I've got mine here. And we're going to have similar interests, or possibly different interests. And so we tailor those fact bricks to select particular data sets and evaluate particular data sets that we care about. And we select evaluation services that we also care about. And the key thing here is that we're selecting others' data sets to evaluate, and we're selecting others' evaluation services to use. So all of this is distributed. None of it is ours. The only thing that is ours is the fact break that we're accumulating. It's the results of the evaluations that we are accumulating, which in turn gets republished as linked data and available for Spark query. But the only thing that we maintain is that the metadata about those data sets that we're concerned about. And so I think that key distinction opens that up to being a framework. And if we don't have the evaluation services that we're interested in, then we create our own evaluation services. But when we use those evaluation services, they're not ours. They're out on the web and they're being used just like it's somebody else's. So in this illustration, we have a particular fact brick that is using an evaluation service and evaluating the same data set that my fact brick is evaluating. But I'm evaluating the same data set with another evaluation service. And I'll get into selector services a little later on. Selector services basically provide you the list of evaluation services to apply and the data sets to evaluate. So when we look at a single slice of the fact brick, we have the data sets along the rows and the evaluation services along the column. And so you look at this as a statistical sample matrix. And the three things that I want to point out here is to be able to get data sets, we're using CCAN over here on the left. You don't have to, but it's very useful to do it. And to obtain the evaluation services and to implement the evaluation services, we're using the SADI Semantic Web Services framework. And then finally, once you've accumulated these RDF descriptions from the evaluation services, we just have a big named graph structure within an endpoint. We're using Alvaro's LOD speaker to be able to both post that triple store as linked data, as well as tailor particular HTML views into any one of these dimensions with the accumulated results. So next I'm going to walk through, we're going to talk about CCAN, and then I'm going to talk about SADI, and talk about how we actually use that. One per slide. So on CCAN, so CCAN was adopted, if you're familiar with kind of the Debian package system where you get software, you just say apt-get install. The CCAN is modeled in that same kind of metaphor, where instead of getting software packages, you get data set packages, so that you just give a single identifier and you kind of get it and compile it and do whatever you want. And so CCAN, so that's kind of the paradigm that CCAN provides, and Richard Sigriak, Sigri had chosen to use CCAN to do this, which is somewhat awkward coming from a semantic web perspective. In that you use either a GUI or a JSON API to get data in. But then once you do that, then you can sparkle and deref out of CCAN. And so in order to do that, you have to follow, so these are the two edit views within CCAN, and in order to kind of get that metadata in to the linked open data cloud, you have to follow some magic formulae, tagging, attribute value structure that you have to know gets decoded into actual RDF. But once you do that, then you're able to describe the different characteristics that goes into the linked data diagram, and that then comes out as well-structured RDF using primarily the weight vocabulary of interlinked data. So I've actually been working with Sigri to be able to actually have a well-structured RDF representation of this that you just post in to a service to make those changes. But ultimately, CCAN is really nice in that you can use a GUI or you can use a JSON API, and you can just make a data set and start giving pointers. And there's a variety of conventions on being able to point to different kinds of data sets. And so you can sparkle query into it. You can dereference the URIs. So it's pretty nice out of the box, and so very good to build off of. I'm amazed that I think I'm able to cover Sadie in one slide. Sadie is amazing. Sadie is web services done right, finally, and it revolves around HTTP and RDF, and so I'm reusing the hello world that the Sadie folks provide. And so the way that you engage with a Sadie service, first off, you need to find out that the thing exists, right? And so you can go to this URL, this registry, register, and you can paste in this URL, the URI of the Sadie service itself, right into that web form there. And it will dereference it and follow a few more dereferences and accumulate all that into a triple store. And so once you've just pasted that one URL in, you can sparkle query for any Sadie service. Okay, so it kind of addresses the discoverability problem. But once you find out that you have this URI of the Sadie service, and again, the reason why we're looking at Sadie is because we want to be able to have a web service that accepts URIs of datasets and returns an RDF description of what that service thinks of it, good or bad, what characteristics are it. So the Sadie service is kind of the interface that one uses to be able to talk to that evaluation service. So here we have a hello world Sadie service URI, and once we know it's a Sadie service, and so we're just going to HTTP get that URI, and we're going to get back an RDF description of that URI, which uses an RDF vocabulary that already exists from the MyGrid project from years past in Europe. Okay, I guess. So the key two important aspects here, the tokens to look for within a Sadie service description are the object type of the input and the object type of the output. And so you just follow these predicates and you get this URI. And these two URIs are URIs of OWL classes. Right? So to understand what a Sadie service means is to HTTP get its description, look at its description, dig out its input and output classes, and then you get to just reuse linked data, semantic web, and OWL to understand what that means. Right? So the Sadie service is saying, I'm going to take in RDF instances of this class, and I'm going to output the same instances also typed to this output class. Okay? So in this example, they accept a named individual, and they return a greeted individual. Okay? And if you dereference that URI for that class, you're going to see some, I think it's a sum values from or a min1 OWL restriction that says you need to be a person, you need to be a folk person, and you need to have a folk name. So if we understand OWL, then we can see that then we know what to give this service. We now know how to talk to this service. And when we dereference the greeted individual URI, I think it says it has a min cardinality or some values from restriction that says you're going to have a greeting property. Okay? So we can now understand what the Sadie service is by understanding the characteristics of the instance that comes out of the service. So we can understand the service in terms of what goes in and what comes out. The essential aspect here is that the same thing that goes in is the same thing that comes out. We'll have that example here. So we have the URI of the Sadie service. We HTTP get it to get its service description. We find its input class and its output class. We use OWL to understand what that means. We can construct RDF that suits that OWL. So here we have Tim Lebo is of type named individual, which is this class here, and it has a folk name of Tim. And we HTTP post this RDF file to that same URI, that same SADI service. Here we just use curl. And it's going to return back to us an RDF description of me, of the same URI that went in. And the new property on Tim Lebo is a hello greeting that says hello, comma Tim. Okay, so we HTTP posted an RDF description about me, and me was a named individual that goes in, and me came out also as a greeted individual, and I have a new property called hello Tim. Okay, so the Tim Lebo goes in, the Tim Lebo comes out, and he has new properties. We have a hello greeting.
And those properties are from the ontology that's on the SADI framework, right? So
Yes,
named individual and greeted individual are in the hello ontology.
Yes, and the greeted individual has a min or a sum values on property hello greeting.
Okay, and what's in the my grid specification? So it's just the input parameter and output parameter.
There's some other stuff, but this is the essential 2 bits. This comes back. The document comes back as typed as a mygrid service description. But yeah, these are the essential.
Years past, to quote you.
Yes, years pass. They're done, right?
So it turns
Or
you
not,
in,
because
it,
Ian's-
so this
yeah.
technically
Sorry,
this
Ian.
turns you into a greeted individual.
Yes. So the important aspect here is I can union this graph with this graph, and that's the whole view. And the instance that goes in is the instance that comes out. So how to apply this to DataFAQs when we're trying to evaluate data sets is that an instance of dcat dataset is going to go in, which is arbitrary dataset. Doesn't matter what it is. And on the output class is going to be a DataFAQs evaluated class. And so when we HTTP post a description about some arbitrary dcat dataset, we're going to come back and we're going to type that same dcat dataset to a subclass of DataFAQs evaluated, which can be, right now it's satisfactory or unsatisfactory, right? Just to keep it simple for now. And so that same dcat dataset is going to be multi-typed, right? It's going to be, I am a dcat dataset, and I am also a DataFAQs satisfactory. And the way that so satisfactory right now, satisfactory within the context of us calling this service at this time. And we're addressing that by maintaining both provenance of that invocation as well as thinking through the named graph organization on the triple store. So I can call again and again and again, and each response is going to be a different named graph. So that I can start to see over time, we're good, we're good, we're good. Oh, we messed up, right? So in one slide, it took a really long time, but we nailed it in one slide. Does SADI make sense? Cool. All right. So we're familiar, hopefully. Well, I've used this image before, right? So we've got this basic statistics matrix of the different evaluation services in the columns and different data sets in the rows. And we're using CCAN to find out what data sets, and we're implementing evaluation services using the SADI framework. And for any one evaluation, right? This is data set 2 being evaluated by evaluation service 1, and this is data set 2 evaluated by evaluation service 2. So what goes into this is first collecting up the metadata about that data set, which we obtain through a URI dereference, as well as dereferencing the void file that also provides metadata. And we also dereference a preferred URI. So that allows us to list it on CCAN, but point to us in log B. So we dereference those three, accumulate that graph. And that graph is the metadata about the data set. And before we do anything with that, we get a service description from the SADI service. So that the SADI service tells us about who made it and things like that. So we would capture that in time. And then we HTTP post that metadata description, the data set metadata description, to the SADI service to get back an RDF description of its evaluation. Right? So we're applying this pattern, this 3, 4, 5 pattern, in every one of these cells to accumulate a collection of evaluations for each of those data sets. And this guy is at the proper level of the nested for loop. So we're not doing it every time. We're doing it once and then reusing the same graph, which is why we're calling it an epoch. And then finally, all of these different graphs get stuffed into different named graphs on the triple store. We have a provenance description of those. We have void description of those, Sparkle service description of those. And we can point LodSpeaker to the triple store and slice and dice and Sparkle query to our heart's content and create cool analysis of what we've collected. And so one matrix here is what we call an epoch. And that's one time slice of the fact brick. So I claimed that DataFAQs is a framework in that I can create and maintain my fact brick. John can maintain and create his fact brick. And those are going to involve looking at different data sets and invoking different evaluation services. So how do we specify which data sets we're interested in? And how do we specify which evaluation services we want to invoke?
So can I actually ask this is a really anal-retentive kind of functional programming question.
Okay.
So you said that because you're keeping track of the provenance of the results, okay, you can there's individuality of each one of them. You see the change over time if there's a change over time. But is the invocation the same in each one of those cases, or is there a difference in the invocation? What I'm ultimately getting at, Tim, is each one of those grid points through every point in time a unique URI.
Yeah.
That's the functional programming sort of part of the question.
And the URI design scheme follows those three dimensions. I don't have a slide on the URI scheme, but
that doesn't matter.
So we follow the same attribute value pattern, and the three attributes are data set, evaluation service, and epoch.
Okay, I get it. So in theory, if caching happened, you can. So the one thing is you got a loudspeaker there, but you don't necessarily, in theory, all you have to do is have done it once, and with the perfect world where things are cached.
Yeah, so I guess two aspects of DataFAQs that we haven't tackled yet are kind of the speed, efficiency type stuff, as well as the caching intelligence. But at the HTTP level, that's already handled for us, right? Because we're doing those requests. But even if they're the same results, we store them. So when that becomes a problem, then we'll turn our attention to that.
Okay, cool.
So John can make a fact brick, I can make a fact brick, he can look at different data sets, I can look at different data sets. So how do we specify what the dimensions are of that fact brick? Well, we do that with SADI, and we do that with W3C's provenance model. So we have this matrix that hopefully we're familiar with, evaluation services in the columns, data sets in the rows. And so we need to find out what data sets we're going to evaluate. And we need to know what evaluation services we're going to use to evaluate. And so really what this becomes is a service composition where we have, I've mentioned these selector services. And I'll list the actual URIs for the deployed services in the next slide. So we need to be able to generically describe that service composition to obtain an RDF description of what data sets to evaluate and obtain an RDF description of what evaluation services to apply. And the way to abstract that into to be able to handle general problems is to pair up RDF inputs with SADI service inputs, or SADI services. So what we're going to say is, I want this URI to be fed into this SADI service selector, which takes in this arbitrary file and returns back whatever, some RDF descriptions of some data sets. And you do that in a series so that you can feed multiple inputs to the same service, and it can feed, invoke multiple services. You accumulate that, you have an RDF graph that mentions data sets. And then to address that preferred URI problem, where we have a log D data set listed on CCAN, but we need to point back to log D and be able to dereference that URI. So there's a second stage here, which we have a data set referencer that you just list, and that data set referencer is applied to the input of all the data sets listings. And then this is just an RDF graph that has a bunch of RDF type ECAT data sets. And in the same kind of pattern where you can have multiple RDF inputs into a SADI service, you can do that many times, you accumulate the results, and now you have an RDF graph of what evaluation services to invoke. Now we just Spark query this, Spark query this, we have a list of data sets, we have a list of evaluation services done. And so this is a graphical illustration. This is encoded using W3C's provenance data model, where you have these guys are agents that use particular inputs, and it basically becomes a template that we instantiate once we instantiate the epoch. And so for even different epochs, you can toggle that. You can start looking at more data sets. So you don't have to be a uniform brick. You can start growing and shrink down if you don't care. And again, this is captured as part of the metadata for the epoch itself. So you can query this graph too to find out what kind of data sets were listed and who told you about them. And so I guess I'm back on. So we've got data set listers, data set selectors, data set referencers, and evaluation service selectors. So selectors and a referencer. And here's the current list of those the evaluation service selectors, the data set selectors, and then the referencer augmenter got renamed to referencer. And so it doesn't take much, right, to be able to, you don't need a lot of these core services to do this. So the identity service gives back what you give it. And then the via Sparkle query allows you to specify the Sparkle query and where it's going to be targeted, and it'll return back, it'll walk the bindings and instantiate the RDF for you. Same to identity and via Sparkle query to get the data sets, but you can also just feed in a CCAN group or a tag, and it'll query CCANs, hopefully the Spark endpoint, hopefully not via the API, and you'll get back a bunch of RDF types, CCAN data sets. of those. And then the augment data, so there's only one that would grab the void metadata file, dereference the URI, and grab the preferred URI. And so that's all you really need to be able to configure. You invoke one of these with a variety of different inputs, and you can instantiate your epoch that you're going to evaluate. So a short list, really the focus hasn't been on just blowing through a lot of evaluation services. Right now the focus has been on nailing down the design and the infrastructure, implementation, as well as the exposing the results. But we have just a couple of evaluation services. So this in Sparkle endpoint, that'll reproduce the log stats and the Sparkle endpoint status. It'll look for the void Sparkle endpoint predicate, try to query into it. If it's anything back, then it flags it yes, you're good to go. As opposed to the named graphs evaluation service, which actually pokes through the entire named graph, all of the named graphs, and emits back a Sparkle service description for all of the named graphs within the endpoint. So this contributor email has been kind of a fun project for me. It's been interesting to see how difficult it is to get contact information for a maintainer of a data set. But for those who have, I've been able to, I actually have a big issues list, issue tracker of log cloud issues on DataFAQs, or where they have parse errors and things like that. And when you actually get a hold of them, they're very responsive. But it's just hard to get a hold of people because they don't have their email addresses. Running an epoch, how do you do it? You just run a single shell script, which pulls out some Python. It follows the configuration within the epoch. This is the W3C provenance description of how to compose the service invocations to get the selected data set select evaluation services. It accumulates the results within a three-dimensional cube on the file system that we stay at the file system initially just because doing it at any sort of object model, really no API can stand on its own as far as handling the different syntaxes and everything else. So it's easier just to get it to disk as quickly as possible and deal with the different syntaxes and things later on. For any result that we accumulate on the system, a sibling file goes right next to it that gives the whole metadata about that file and when it was invoked, describing the provenance of that, describing the void and the Sparkle service description of that graph, and determines the named graph organization. Every call is a different named graph, and all of that gets published onto the web as dump files, and then they get loaded in TripleStore, and then we're off and running with LogSpeaker. So one thing that I was particularly happy with the way that this design fell out is that we can actually mirror the TripleStore by accessing all of the dump files of the named graphs within the TripleStore just by querying the TripleStore itself, using only void and the Sparkle service description, where we just say, hey, give us the dump file as well as list us the number of triples, and so I just click on that query and we'll have to the result. So most of them are there. So here we have the local name, local graphing. And here you get the URI design that you were asking about. Every graph we retrieve follows this attribute value pattern. How many triples? So these are small because these are the evaluations that come back. Really, you only need one triple, plus or minus, good or bad. And then a link to the dump file itself, which is just mirrored from the directory structure that we created. So it's one nice design aspect of anything that we do is immediately available, and anybody can mirror how we're acting. So looking at this query, we can see that there's named graphs hanging around. And now that we have named graphs within a triple store, we can fire up LODSpeaker. And really my motto these days, when in doubt, fork LODSpeaker. I think I've forked LODSpeaker 3 times already for just every different project that I'm working on that I need to just quickly present some RDF data. We're actually starting to use it to write up the OWL encoding W3C rec, which is pretty exciting. That it's that flexible. And so if you're familiar, and you should be familiar with the LODSpeaker hierarchy, this is just one hierarchy for me handling the instances of DataFAQs epoch. And I have a bunch of queries that I execute, and then all of that gets accessible through the HTML template, where I start piecing together the HTML tables and or passing it through as a JSON object and visualizing the D3, which is still on the plate. So with that, I'll show you some slides and then finish up with a slide of conclusions. So this URL is working. This is where I've deployed the Microsoft. So the nice thing about DataFAQs is when you want to create your own fabric, you get, so DataFAQs is on GitHub, so you can get cloned. The LODSpeaker specific for DataFAQs is on a separate repository on GitHub. So you just do 2 Git clones, and you can fire off an epoch and do an evaluation. So here on the home screen, I'm just querying some folk names. This is going to end up being a tag cloud, just kind of motivate people like, why is my name there? That's cool. Click on it and have some person-centric view of the data sets of what evaluation services they've created or what data sets they're maintaining. And so the evaluation services that are known within this fabric, oh yeah, so for installing, you do those 2 Git clones, and then when you instantiate when you install the LODSpeaker, you just point it to a triple store. And so you can actually point it to anybody else's fabric triple store and just start navigating theirs or tailoring your own views to theirs. So here we have a listing of the evaluation services that were used to get some duplicate results. Not sure why yet, but here I was doing an analysis looking for what Sparkle endpoints were up, as well as what data sets had metadata that pointed to a contributor, either a DC terms contributor with a folk inbox, or there's this predicate floating around with data, OO:corrections, that is an email address that you're supposed to email and they'll respond, which has happened, so it worked. So here, just kind of being able to see any evaluation service used within that entire brick. And then looking at the data sets that this fact brick knows about, here I just cherry picked from LODStats, one that they knew didn't have an endpoint and one that they knew did have an endpoint, and then I verified by hand. I think this number's wrong, but the idea is that there's going to be a distribution here. If you stop looking at data sets over time, then that number is going to stop being counted. And then the epochs. Oh, I didn't put that over. In the epochs, so I've run 4 time slices. One was 2 days ago, and when you dig into an epoch, prepare for a really ugly web page. It's even ugly. Oh, it's empty. That's terrible. How about 218? And then in here is basically walking through all of those individual graphs that we've accumulated. as well as providing references to the dump files, what data sets were evaluated. But here, the idea is that, and it's very frustrating because all that data is right there. It's right in the triple store. It's just a matter of stitching together these queries and putting up these analyses. But the idea is that you get the overview when looking at just the epoch, and then as you click down, so here we're evaluating the U.S. Census 2000, which is the first one that's always listed on unlinked data. But when we go to it, we're actually going to our local URI, contextualized by the time that we actually did it, so that we can show you that snapshot of this particular data set. And they're associated through a W3C provenance relationship.
So we're looking at the U.S. Census data as of February 18th.
Yeah, but you're sneaking at the. Oh, we fell into the default view, which isn't actually. So yeah, we're the February 18th version of that data set.
Right.
So it's our view of that data set on that day.
Right.
And I think so. These two are named graphs, and the named graph actually they're void data sets that have a primary topic of that data set. In the SD name. Provenance, specialization of the actual data set. So you get this kind of SCOS broader aspect that all of the temporally contextualized data sets are binned under the generic URI for the data set. And again, each one of these URI dereferences gets handled by loudspeaker, so we have loudspeaker control over based off of its URI or its type or a particular service to be able to invoke Sparkle queries to craft whatever view we need, and then obviously get resolvability for free through loudspeaker. So. Yeah, so now it's just a matter of writing Spark queries, making web pages, showing graphs, because it's there. So I'll hop back to the conclusions and then call it a day. So what do we talk about? Well, there's lots of tools to produce linked data. There's some tools to evaluate linked data. But I think the problem with what they're doing is that it's too heavyweight and it's too centralized. They've been focusing on how, and we should be focusing on how well and why. We should not be looking at publishers, we should be looking at consumers, and we shouldn't be building systems, we should be building frameworks. And so the answer to that problem is DataFAQs, which is a framework that allows micro-contribs via implementing individual evaluation services or instantiating your own fact brick to perform your own analyses. And creating a fact brick within DataFAQs revolves around choosing the data sets that you want to evaluate, where we use CCAN to do that, choosing the evaluation services that you want to apply, we use SADI to do that, and exploring the evaluations, where once it's in a triple store, we use loudspeaker to do that. And so I hope you want to try it, give it a shot, and let me know, and finish up with some thank you to these great fellow students of mine for their help on the design of DataFAQs. And with that, I thank you for your time.
So could you project a little bit about how it could be used, actually, how it could be fed back to the creation of linked data, or creation of high quality linked data? So imagine you were to include this as part of the workflow.
Right. So if you create a fact brick and I create a fact brick, and they're available on, in the triple stores, and they're available as linked data. If we mix in some notion of registry, or we're able to find all of the fact bricks that are available, then we're able to tap into the community's, an expression of the community's interests and an expression of the community's perspectives. So, and that boils down to what data sets are they looking at, what characteristics do they care about. Okay, so there's some community analysis that can happen there. And if you identify the good, the popular or whatever have you of the evaluation services, then you have that collection available to you. And that can be tailored to you, the curator, or you, the converter guy. And if you can point your, as in your workflow of while you're creating those conversions, you basically have that list of the good characteristics.
Yeah.
So every action that you take in, well, I think I want to promote that thing to a folk person. You get these little brownie points because that gets fed. You can help. If hypothetically do that conversion and apply those evaluation services, you just fire them off, right? A couple of rows worth to those evaluation services, and you see that spike in that quality.
So Matthew Block is the name of a guy who does a lot of the New York Times infographics.
Mm-hmm.
We can imagine Matthew Block is looking for certain things, and in fact, he creates his own fact brick or a couple fact bricks. Maybe he's got different kinds of infographics. If we want to create linked data that we know meets his criteria as characterized by his fact bricks,
Mm-hmm.
we make sure that
We could get on the paper.
Right.
We get on the Times.
well,
So
we would create data that we know would
Yeah.
would be perfect for him based
Yeah.
on how he articulates.
Right.
And then we get on New York Times.
Right.
or the Guardian, that sort of thing, or et cetera. That I get. It's pretty
Yeah, so one use case that I laid out for a web science abstract a couple of weeks ago was kind of based off of this email access contact thing, right? Where you have a single voice that turns into a voice of many. In that, so you having contact with whoever's curating the data set is pretty important, right? So we had a researcher, this hypothetical researcher that ran into a problem in a data set, couldn't get a hold of the data set owner. And so to kind of look ahead on how to avoid that in the future, she implemented this evaluation service and then applied it to all of the data sets that she uses in her daily work or in the course of her research, and finds that 20% or whatever just isn't only 20% is contactable. So she sends out frustrated tweet or to her colleagues or whatever, and they also want to be able to make sure that if they ever run into any problems with their data set, and so they just invoke her evaluation service for their data sets. And if you have a common data set that is starting to fail miserably over all of those fact bricks, then the owner or curator of that data set is starting to get the voice of many on, oh wait, we're doing a really bad job. People really care about this aspect, and we're not doing it. And so they solve the problem. And to avoid future problems, they set up their own fact brick that allows them to monitor what they're doing as they go through their workflow cycles. And then that turns around and can become just a point of advertising on if, so you get this little DataFAQs badge, right next to any data set listing that says contactability 700 out of 1400. And so, yeah, I really think that being able to decouple an isolated evaluation service and to allow anybody in the community to host it and to offer it up, you can then compose across that network, and you get some really nice effects.
I can imagine this in an enterprise scenario.
Yes.
This is grouchy old guys with the great suits get their hands on this inside of corporations and governments. It's really good. Other questions? I was wondering, we might want to do this as an after thing, but Chris might be interested in he might have his own questions, but he didn't show any of loudspeaker.
Yeah,
And, and loudspeaker's pretty interesting about how that's configured, so
yeah,
we don't have to bore everybody with that.
it's great.
Yeah, I don't have to actually kind of look at it.
Yeah.
What's interesting is that, we deal a lot with sort of the part before it ever gets to RDF. You were saying that there's sort of a lot of tools at this point that are very good that already convert data into RDF triples, and
There's a lot.
I think you
Right,
wickedly
well-
exaggerated
Well,
the status,
that's all
the state of the, yes, there are those many
Because-
things,
and more.
and more.
because I've seen the state of government data in very granular detail, and there's some places where there's very little documentation. So as far as building and triples of certain data sets, there have to be a lot of assumptions that are made about what that data are.
Mhm.
And so, in some ways, these are evaluations. This is sort of evaluations of the triple stores, but it's it's after the triples have been
Well,
created.
no, it's
right?
generically it's a data set evaluation framework. So as long as you're describing that data set in RDF, the contents don't have to be RDF.
Sure.
And you can leverage that network of evaluations.
Right. I mean, we're very interested in sort of evaluation of data sets and especially metadata, but it doesn't actually, at this point, we don't have a lot of data in RDF. So it's similar but not.
So are you saying, just to check, so I think you're picking up on this, you could have a service which tests CSVs in some way.
Yeah.
Every one of those, those checkers can be some kind of test of CSV, and you've got
So that you right, so DCAT data set is generic data set, right? It's any arbitrary notion of Flickr images or
right.
Esri, whatever, right? Shape files, anything. So you could have format checkers, format guesser services that just takes in that URI of the data set. You gotta give it a URI. Make it. You can describe it in linked data without actually being linked data. And then you have the Esri checker that just starts spiking on, hey, this is an Esri file. And then that comes out as RDF, or DC terms, format Esri or something. And then you can just query your fact brick for, hey, I need Esri files. And you didn't know it before, and now you do. And so you can actually use that to be the engine of the workflow to push it down all of those stages, where you just query into the fact brick to find all of the elements that are in a particular stage. So if it's georeferenced or it's not georeferenced, depending on whether or not it went through the georeferencer. So yeah, you don't, the contents doesn't need to be RDF, but you should be describing the data sets in linked data to begin with.
Right.
Just grab the file, give it a URI, make it referenceable, and you can do something with it. VCAT, access URL.
Any other questions?